Okay, welcome back. We are still continuing with lesson 3.1. This is part 3. To continue with these examples that we have, and we're trying to find slope intercept. So, whenever you're trying to find the slope of a line, okay, so this value here, this is the slope, okay, that's our slope. And so the question is, how do we calculate that number, especially if the relationship we're looking at isn't that easy to find? Well, the nice thing is the slope of any line has a relationship that we can always look to, and that is y2 minus y1 is always over x2 minus x1. And so it's the rise, how much we go up by on the y-axis, over the run, how far we're going from side to side on the x-axis. So, for example, for this particular problem, we know that it was 3. Well, how did I know that it was 3? Well, I can take any values from this table, and I can plug them into this y2 minus y1 over x2 minus x1 and find that slope value. And it really doesn't matter which values I choose as long as I use, a value that's higher from a value that's lower. So for example, if I pick 8 and 5 as my y2 and my y1, I'm going to have 8 minus 5 over, and then I got to pick the x values, which would be 0, 0, minus -1, okay? And so if I do that, well, let's see, what's 8 minus 5? 8 minus 5 is 3. And then 0 minus -1 is just +1. So that means I've got 3 over +1. So that means it equals 3. So that's where I get my slope. Okay. Over on this problem, I can do the exact same thing. I can look back to my values. So I'm going to look at one number that's higher than another. So for example, I'm going to look up here where we have y is equal to 4, okay? And notice that when y is equal to 4, that x is equal to 2. And then I can go to where y was equal to 3. So I'm going to this next one. Y is 5, 4 minus 3. And when this is 3, this ends up being 4. So notice we have 4 minus 3, 2 minus 4. What does that equal? Well, that equals -1/2, right? Because 4 minus 3 is 1. But 2 minus 4 is -2, which makes this whole thing -1/2, okay? All right. So continuing with that, let's look at this next problem where it asks us to find the linear equation. Oops, sorry. There we go. Find the linear equation in slope-intercept form for these two examples down here. So we have a data table, and then we also have a graph. So if we look at the first one, so we want to look at the slope-intercept, okay? We want to look towards this first one, and we'll just kind of slide this aside. All right, so let's see what we've got going on here. Well, do we have a y? Do we have two y values and two x values that go together? And the answer is absolutely. So we start with this top one. So we know we've got 14. That'd be our y2 minus 5, our y1. And that's going to be over 4 minus -2, which just means +2, really. So when we calculate that, well, what do we have? Well, 14 minus 5 is 9. And 4 plus 2 is 6. So we've got 9, 6. And that's going to reduce nicely down to 3/2. So that tells us that in front of this x, the slope should be 3/2. Okay? And then all we need to do is figure out what would this next number be? Well, to do that, all we really have to do is put in the formula. Okay, so now we know that we've got y equals 3/2 x plus b. We're trying to figure out what the b is so that we can complete this equation. Well, to do that, we can easily substitute some values in here. So I'm going to go with this one here, which is we know y was 5 and x was -2. So if I know y is 5, I'm going to substitute that in for y, and that's going to equal 3/2 times -2, and that's plus b. And then we can just solve for b. And so if I take 3 times 3/2 times -2, and then subtract that value from both sides, I get that b equals 8. Okay, and that's my slope-intercept formula. 3y equals 3/2 x plus 8. Okay, now for this next example, we can do the same process. Okay, so let's find some room here. So let's do a couple things. First, we are going to pick 2 points on the graph. That's the beautiful thing about a slope-intercept. We only need 2 points on the graph. So here are the points I'm going to choose. I'm going to choose -4, which is at 3. So if I go over to -4, go up, it's at 3. So that's 1 point. And then the other point I'm going to choose is -3, 6. If I go over to -3, notice it goes up and I've got a point at 6. Okay? So there's a couple of points that I can use. Step 2, let's calculate the slope. Okay, and that's pretty easy. We can take our largest y value, 6, minus our smaller one, 3, and then the corresponding, let's see, -3 minus -4, which really just turns into +4. And that tells us that we are going to have, let's see, 6 minus 3 is 3, over -3 plus 4, that's 1. And that means we've got 3. So our slope is 3. Okay, pretty simple there. Then our third step, we're going to substitute. We've got our equation y equals 3x plus b. We want to solve for b, so we're going to plug in a point from that graph. It really doesn't matter what point we plug in. Although I can tell you this, a good thing to do here is we can look to see if it ever crosses anywhere at the 0 mark, or we can set y to 0. That's another really good one, because we can see when y is 0 on this axis, right? So I'm going to set that. I'm going to have y is equal to 0, and that equals 3. Well, what's x when y is 0? Well, it's 1, 2, 3, 4, -5. So it's -5, and we've got plus b. And so now if I do this, 3 times -5 is -15. So I'm going to get -15, and then I just add 15 to each side to get rid of it, and I'm going to get a value of 15. So our b value is 15. So that means for this equation, y equals 3x plus 15. Anytime I put in an x, I'm going to multiply it by 3, and I'm going to add 15, and that would actually give me this relationship there. Okay? So now let's look at some relationships. Talk about linear versus not linear. Okay? Linear and not linear. It's pretty simple, really. Linear are nice straight lines. Okay? They can increase, they can decrease, they can go straight across, but the thing is they're a nice straight line. So this is linear, this relationship is linear, this relationship is not. Okay, that is not linear. Now that's not to say that there are not functions that will show us that relationship. It just doesn't happen to be linear because it doesn't go in a nice straight line. It's not increasing at a constant rate. That's the definition of a linear relationship. It's going to increase at a constant rate. This also not a linear relationship. This is one of our exponential. Okay, exponential, they're not linear. All right. Okay, so we'll just look at this last little page then. And so when we're talking about linear, can we come up with a description of a set of characteristics of a linear relationship? Well, we sure can. First, the graph is in a straight line. Okay? And the rate of change is constant. Okay? And that rate of change, that constant, that's what that m value is in that slope-intercept form. We've got m times x plus b. Starting point or y-intercept is always going to be b, okay, for a linear relationship. So when we're looking at the y equals mx plus b, those are linear relationships. So now let's look down here.